Have you ever really thought about what happens the exact moment you hit send or press enter? I mean, what's the very first tiny step your data takes to get from your screen out to the rest of the world? That's what we're going to break down today, that very first leap of faith into the internet.
So it all comes down to this, right? How does your data find the front door? Think about your home network like it's a little neighborhood. You've got your computer, your phone, maybe a smart TV. They're all houses on the same street. But how does a letter from your house even find the main road that leads out of the entire neighborhood?
Well, that's the first problem we have to solve. Just leaving your local network. It's easy for all your devices to chat with each other because they're all inside this digital bubble. But to get a message to the outside world, you gotta pop that bubble.
And here's where you see a huge difference. Your computer sending a file to your printer, that's a local conversation. They're neighbors, they can talk over the fence. But talking to a website halfway across the world, that's a whole different kind of journey. It needs a very specific exit.
And that exit has a special name, the default gateway. For pretty much all of us, this is just our home router. Think about it. Every single piece of information trying to leave your house has to go through this one single point. It is literally the only road out of your digital town.
Okay, but here's the catch. Your computer knows it needs to send data to the gateway, but that's not enough. It needs to know the gateway's physical hardware address, its MAC address. It's kind of like knowing you need to get on the freeway, but you don't know the exact physical location of the on-ramp. You can't get there without it. So that brings us to the really clever part. How does your computer find this super important address? It doesn't just guess. It has this really elegant process for basically just asking for directions.
So your computer runs through this quick little checklist in its head. First, it looks at the destination and asks, hey, is this IP address one of my local neighbors? The answer is no, so it makes a decision. Okay, I'm not talking to them directly. My one and only job right now is to get this to the gateway. And that leads to the final step. It has to ask.
And the way it asks is by using something called an ARP request. ARP stands for Address Resolution Protocol. And honestly, it's the digital equivalent of your computer standing in the middle of the room and just shouting, "Hey, everyone, does anyone here have the address for the gateway?" And that shout goes out to every single device on your network. Your phone, your tablet, your smart fridge, everything. But they all just ignore it because the question isn't for them. Only the router, the gateway, recognizes its own IP address in that question and raises its hand and says, "Oh, that's me. Here's my physical MAC address." Now, once your computer gets that answer, it doesn't just use it and forget it. That would be so inefficient. Instead, it jots it down in a little digital notebook called the ARP table. It saves that IP to MAC address mapping so it doesn't have to shout the same question over and over again.
All right, now we get to the main event. This is the moment we've been building up to. The computer has the address it needs, and it's finally ready to send your data on its very first hop toward the internet. And this is probably the most important idea to get right here. Your data is like a letter. We call it a packet. And it's addressed to its final destination, like a website's IP address. But to get there, it has to be put inside a local delivery envelope, which we call a frame. And that frame is addressed only to the very next step, the physical MAC address of your router. This chart breaks it down perfectly. The packet cares about the long-haul journey, the frame only cares about the very next stop. So your computer wraps that long-distance packet inside the local delivery frame and sends it off, not to the internet, but directly to your router. So what does the router do when it gets that frame? It acts like a mailroom worker. It rips open the local envelope, the frame, and pulls out the letter inside, the packet. It looks at the packet's final destination address and says, aha, I know the next step to get this closer to where it's going. And then it forwards that packet along to the next router in the big, wide internet. So, okay, we've walked through the mechanics. But why is this one little step so unbelievably important for how the whole internet works? Well, for one, it's all about efficiency. Remember that little ARP notebook? The entry for your gateway is special. Your computer hangs on to that information way longer than any other entry, simply because it's using it all the time. This stops it from constantly shouting for directions every single time you click on something. But here's the bigger picture. Without this simple local process, the entire global system of routing, of your data hopping from network to network to network all across the planet, it just can't happen. It's impossible. If your computer can't find its way out of its own neighborhood, the journey can't even begin.
And that really just says it all, doesn't it? This quiet, little local conversation between your PC and your router is the absolute bedrock of everything we do online. It's the real unsung hero of how we connect to the world.
So we made it. We navigated that critical first hop. But that just gets our data to the edge of our own network. What happens next? When your router sends it to the next router and the one after that, how do they know where to go? Well, that's a whole other journey.